Have you ever found yourself thinking about how amazing it would be to know what will happen in the future? What if we could travel through time, see future events, and even change the past? It sounds like science fiction, doesn't it? But what if I told you that scientists are getting closer to unraveling the mysteries of time paradoxes? Time travel has always been one of humanity's greatest dreams, fueling our curiosity and desire to explore the unknown. Imagine being able to travel through time, visit different eras, and witness historical events firsthand. However, the question everyone asks is, if time travel is possible, where are the visitors from the future? It's a mystery that continues to intrigue scientists and philosophers, as the absence of evidence raises many questions. Although time travel is a popular concept in science fiction, bringing fascinating stories and incredible twists, many experts argue that it is impossible. There are biological and philosophical barriers that seem to make this idea impractical. The time paradox arises here, because if we could really travel through time, how would it impact our lives and the very structure of time? Time, as we understand it, may not be a simple linear progression. Our memories and expectations shape our perception of time, creating paradoxes that challenge our understanding. This possibility of time travel raises even more questions about how our perception of the future and the past can be altered. Speaking of paradoxes, let's now explore the famous time paradoxes that so intrigue scientists and enthusiasts. The time paradox is an idea that challenges our linear understanding of time. Instead of a continuous and predictable flow, time can be seen as a complex tapestry woven by our memories, expectations, and beliefs. This concept changes the way we perceive events and experiences, leading to seemingly contradictory situations. Imagine if our memories could directly influence the future, creating an endless cycle of causes and effects. Our perception of time is far from objective. Each of us lives in a subjective time, shaped by personal experiences and the interpretation of events. This can result in fascinating time paradoxes, where what we expect and believe about the future can, in fact, influence the present. These paradoxes not only challenge logic but also make us question the nature of reality and time. Time paradoxes show how our lives are intertwined in a network of events that defy linear logic. As we explore these enigmas, we begin to understand how our mind and perceptions influence our experience of time. This phenomenon opens doors for deeper discussions about specific types of time paradoxes, each with its own intriguing implications. Consistency paradoxes are a real puzzle for the mind. Imagine traveling through time and accidentally altering a crucial event in the past. The grandfather paradox is a classic example. Imagine you have a time machine and decide to go back to the past to meet your grandfather. For some reason, a series of events leads to his death before he has a chance to meet your grandmother. This act would prevent the existence of your parents and, consequently, yours. This creates a contradiction. If you were never born, how could you travel back in time and kill your grandfather? This paradox exposes a fundamental flaw in the logic of linear time travel. It suggests that interference in the past could alter the timeline in unpredictable and potentially destructive ways. The grandfather paradox forces scientists to reconsider the structure of time and causality. Is time really malleable? Or are there natural mechanisms that prevent such changes to preserve historical consistency? Another example is the Hitler assassination paradox, one of the most discussed examples of how time travel could alter the course of history unpredictably. Imagine you travel back in time with the mission to eliminate Hitler before he rises to power and starts World War II. The idea seems simple. By removing a central figure, many subsequent horrors could be avoided. However, this action raises a series of questions about the unpredictable consequences and the integrity of the timeline. If Hitler were assassinated before causing the devastation of World War II, the course of history would change radically. Without the war, technological, geopolitical, and social development could follow completely different paths. But here's the paradox. By changing these events, you could create a new reality in which the need to travel back in time to kill Hitler never existed. This creates a temporal contradiction. If there was no war, you would never have the motivation to go back and prevent something that never happened. Moreover, eliminating Hitler could result in an even more dangerous leader emerging or a series of equally catastrophic events. Attempting to solve a problem in the past could inadvertently create new problems in the present. This paradox illustrates how our actions in time are interconnected and how a change in the past can have unpredictable ripple effects. With this in mind, we move on to the Polchinski paradox, which presents another fascinating layer of complexity in time paradoxes. Causal loop paradoxes are equally fascinating and complicated. Starting with the predestination paradox, it is one of the most perplexing time paradoxes, challenging our notions of free will and causality. Imagine a time traveler trying to prevent a tragic event, like the fall of a vase that injures a pedestrian. By intervening, he inadvertently pushes the vase, causing exactly the accident he wanted to avoid. This paradox suggests that certain events are inevitable, even with direct intervention, and that attempts to change the past may actually be the catalysts for these events. This paradox questions whether we really have control over our destinies or if we are trapped in a predetermined sequence of events. In the predestination paradox, the time traveler becomes an integral part of the chain of events he intended to alter, suggesting that time has a way of self-correcting. It's as if time has an intrinsic resistance to change, forcing events to occur exactly as they should, despite attempts at interference. Another causal loop paradox is the bootstrap paradox. Imagine a scientist in 2050 who finds a time machine construction manual and travels back to 1950, leaving the manual there. A scientist from that time finds the manual and uses the instructions to build the first time machine, which is eventually used to send the manual back to 2050. In this case, the manual appears to have no clear origin, existing in an infinite loop of cause and effect. This paradox raises profound questions about the origin of information and objects. In the bootstrap paradox, the object or information has no point of creation, it simply exists in an eternal cycle. This challenges our traditional understanding of causality, where every effect must have a cause. In the case of the construction manual, it was never actually created by anyone but always existed in a time loop. This idea is fascinating and unsettling, suggesting that time can operate outside the boundaries of known physical laws. The bootstrap paradox also has philosophical and metaphysical implications. It questions the nature of reality and existence, proposing that some aspects of our universe may be self-sustaining and self-generated. Additionally, it highlights the complexity and interconnectedness of time and space, suggesting that our understanding of these concepts may be limited. As we delve deeper into these paradoxes, we realize the need to explore theoretical solutions to the dilemmas they present. The timeline protection hypothesis is one of the most intriguing theories proposed to resolve time paradoxes. It suggests that the universe has an innate mechanism to prevent time travelers from making significant changes. Essentially, it's as if time has an immune system that protects its integrity. For example, any attempt to kill the grandfather in the past would inevitably fail due to unforeseen circumstances, preserving historical consistency. Another fascinating solution is the multiverse hypothesis, which proposes the existence of multiple parallel universes. According to this theory, every time a significant change is made in the past, a new timeline is created. This means that the time traveler can visit the past and make changes without affecting the original timeline, but creating an alternate reality. This idea not only resolves time paradoxes but also opens up an array of infinite possibilities for destiny and reality. Novikov's self-consistency principle is another interesting approach. This theory states that any event that causes a paradox or alters history has a probability of 0 of happening. In other words, the laws of physics prevent time paradoxes from occurring, ensuring that the timeline remains consistent. For example, any attempt to travel back in time to alter a significant event would simply fail or result in an outcome that keeps history unchanged. The very concept of spacetime offers an intriguing possible solution to time paradoxes. This theory suggests that time and space are not separate entities but rather parts of a four-dimensional continuum that curves and deforms under the influence of mass and energy. In an intense gravitational field, such as that of a black hole, time can be dilated in such a way that normal laws of cause and effect are altered. This flexibility in the fabric of spacetime could, theoretically, allow paradoxical events to be accommodated in a way that does not result in contradictions. One of the ways spacetime can resolve time paradoxes is through the creation of closed time-like curves. These curves allow an object or information to return to its own past without violating the laws of physics. For example, a time traveler could follow a path in spacetime that takes him back to the past, but by doing so, he would be following a route that is already predestined in the fabric of spacetime, avoiding paradoxes like the grandfather paradox or the bootstrap paradox. This suggests that the universe may have a mechanism to ensure temporal consistency through its own structure. Additionally, time dilation, an effect predicted by the theory of relativity, can serve as a natural form of protection against time paradoxes. When an object travels at high speeds or near an intense gravitational field, time for that object slows down relative to an outside observer. This means that any attempt to significantly alter the past would be drastically limited by relative time. This effect could act as a natural barrier, preventing changes in the past from causing major inconsistencies in the timeline. Thus, the concept of spacetime not only helps us understand the nature of the universe but also offers an elegant solution to the dilemmas presented by time paradoxes. And so, we come to the end of this fascinating journey through the time paradox and its many implications. Although the idea of time travel is incredibly appealing, it brings with it a series of challenges and questions that we are still trying to answer. Whether through consistency paradoxes or complex causal loops, time continues to be one of the greatest mysteries of our universe. Science is always advancing, and with each passing day, new discoveries bring us closer to understanding these phenomena. Who knows what the future holds? Perhaps soon, we will have answers that today seem impossible. And that is precisely why you cannot miss following our channel. So, if you enjoyed this video, don't forget to subscribe to the channel and activate notifications so you don't miss any new content. See you next time.